All right, let's take a look at page 52. Yesterday we were looking at function notation and how we can begin to think about what is this asking us to do, what are we trying to find, and we've been relating it to graphs. So are we looking for intersection points? Are we looking for above x-axis, below x-axis? Are we looking for one function above another, one function below another? We have all these different characteristics that we can identify, in addition to domain and range. And it's all related back to the way the function notation is written. Okay, so we're going to do a little bit more today, and you're going to have to help me out. I know we're on page 52, I just forget which one we left off with. We did that one, or we need to do that one? We need to do that one. Okay, so let's take a look at the very middle. Think about what is the notation asking us to identify about the graph at the top. Just a refresher that F is the dotted line and G is the solid. So what is this math language, if you will, telling us to do? What do you think, Sebastian? Okay, so we got to take a look at the picture and figure out the intervals where the dotted graph is above the solid one. F of x is above g of x. So if you want to think about dragging your pencil across, it looks like as we drag across, we get to the x value of -9, and we have a dotted graph above a solid one. And as you continue to drag your pencil across, it kind of changes at this intersection point. So we definitely have one interval. As you continue to drag your pencil across, I don't know if we get any other place where the dotted is above the solid. Notice how the solid one ends at 11. It has that closed circle. So that's where our comparison would have to stop, because you can compare two things. If one of them ends, you don't have anything left to compare to. So let's go ahead and write the interval for that little section. So it started at -9, and it ends at the intersection point, which I think we said yesterday was about -1/4 or half, whatever you roughly guessed. So we got to ask ourselves, brackets, parentheses, can we include these values? Can we not include these values? What do you think?
Both of our parentheses.
Why?
Because -9 is an open dot, and then -1/4 is the intersection point, so it's not technically above.
There you go. Anything for the office today? I think we're good. Thank you. Have a good day. All right, so I heard your justification for that open circle. What did you say about the intersection point again?
It's where it intersects, so it's not actually above it.
That's where they're the same. Right. So notice how the question at hand is, where is the f of x graph above the g of x1? Okay, we have to answer that question. So at this, bless you, at this spot, the f and the g graph are equal. One is not necessarily above or below the other one, so we cannot include that spot. That's why we get that parenthesis. All right, let's try the next one. F of x is greater than 0. What should we be trying to identify on the graph? What are we looking for? Can we think about what that means? Go, Sebastian. Okay, so the specific f of x graph is above the x-axis. Okay, remember f of x is the same thing as 0. So this is, or sorry, f of x is the same thing as y. And this statement is basically saying y is greater than 0. So if you think about a graph, all the y values that are bigger than 0 are above the x-axis. So we got to take a look at where the f of x graph is above the x-axis. So f of x is dotted. If we want to highlight the section or sections where f of x is above the x-axis, looks like we have that. So let's drag our pencil, see where it starts. Looks like -9 and ends at 1. We got to ask ourselves at those spots, are we above the x-axis, and do we actually have closed circles there to physically count? You want to keep going, Alex? Yeah.
They're both parentheses because -9 once again an open dot or circle.
Mm-hmm.
And one is on the axis, not above it.
Not above it. Okay, so this one's a little tricky. This open circle is above the x-axis, so we're technically answering the question at hand, but we do not have a physical point there to actually count or actually exists. So this has no choice but to be a parenthesis. And then Alex stated that at 1, we are not above the x-axis because we are on the x-axis, so that one must have a parenthesis. Is that it? You see another one? Yeah.
The line continues going forward, which will simulate across, and then go on.
Okay, so we have that arrow. It's asking us about the dotted graph. So that arrow from the dotted will continue. So at some point, it will cross the x-axis and then continue on forever from there. The question is, where does it first touch that x-axis? Yeah? 15. I think we said that for a previous one, right? So this one would go from 15, and then if it's going to continue to go upwards forever, it will be above the x-axis forever. We can go all the way towards infinity. So brackets, parentheses, we got to think about it. At 15, we are on the x-axis, not above it, so that would be parenthesis, and we will never ever reach infinity, so that would be a parenthesis as well. Okay, so be careful with that arrow. Okay, there's some more hidden information further on the graph. Let's try the next one. G of x, so the solid one, is increasing. So if we take a look at the graph, maybe we can highlight those sections. Okay. It is wanting us to describe this in words, so if g of x is increasing, you could say g of x goes up from left to right. Okay, so as you read a graph from left to right, just like you would a book, the graph is going up. Okay. So we have 2 intervals to identify. Looks like the first one goes from -3 to +3. We got to ask ourselves, bracket or parentheses? Are you increasing at -3? Are you increasing at +3? What do you think, Adam?
Staying the same.
Say it again?
Would it be staying the same?
What do you mean staying the same?
Like, it isn't going up, really.
Mhm.
It's just, like, there. Pretty much.
It's just, you mean for this one right here?
Yeah.
Okay, so it is just there. It is I'd say a change in direction. So instead of increasing this way, we continue to we increase that way. So it's, notice how if you're standing at this point, you're not necessarily increasing in the same direction anymore. So I can understand why you're saying it's kind of just there. Yeah.
Why don't we have -6 on included? Isn't it increasing?
Oh, yeah. How about we include that whole interval? That would make more sense, right? Because this one, I'm sorry, this one wasn't really a change in direction because we increased both times, right? So I cut it off a little too soon. So we'll do -6. Do we like that one better? Okay. So let's think about -6. I would say -6 is a more concrete change in direction. So we go from constant to increasing. If you're changing direction, you're not just increasing at that spot. So we would need that parenthesis. At 3, we have another change in direction. So if you're changing direction, you're not just increasing. So we cannot include that one either. All right, and then we do have the other section, so we'll throw in the U. We go from 9 to 11. 9 is a change in direction, so you're not just increasing there. And 11 is an endpoint, meaning you stopped moving, so you are not increasing anymore. we cannot include that one either. I think we discussed, whether it was either yesterday or last week on Friday, how if we have increasing, decreasing, or constant, they're always parentheses, right? Okay, it's the other ones that might be a mixture. So increasing, decreasing, and constant, we'll always use those parentheses. Okay. All right, let's try the next one. G of x is decreasing, so we can say g of x goes down from left to right. So it looks like we have that section. And we go from 3 to 9, parenthesis, parenthesis. All right, and the last one, g of x is constant. So g of x, I don't know, stays flat, stays straight, whatever wording you want to use. From left to right. So we just have that first interval and we go from negative 11 to negative 6. Parenthesis, parenthesis. How are we doing so far? Pretty good? All right, we're going to try some more. All right, page 53. We have basically the same graph as before. So it's the same f of x and the same g of x, but they're going to ask us a little bit more information for this one. Now, we did say that the equation of this line was 1/2 x minus 7.5. Okay, we may need that, we may not, who knows, at least we have that information. So let's take a look at these questions. This time they're asking us about f of x, increasing, decreasing, or constant. So in words, we can say f of x goes up from left to right. That's not distracting at all. All right, so dotted graph, increasing. That's not distracting either. Looks like we only have this section. So we can identify from 3 to what? Yeah, infinity. Good, all right. And if we're increasing, those are always going to be parentheses. I always wonder why they have to do this during the school day. All right, for next one, decreasing, we have that interval and this one, so we're going to have to use a u at some point. Our first one goes from negative 9 to negative 7, parenthesis, parenthesis. And the next one goes from negative 1 to 3. Yes? I didn't hear a word you said. Did I miss it? Oh, it's 1 off. Yep, negative 6. All right, so then constant. All right, we stay flat. And that interval is from negative 6 to negative 1. All right. Next one, f of x is less than 0. What should we be trying to find? What do you think, Adam?
The x value from f of x is below the x-axis.
Alright, f of x below x-axis. So, dotted graph, where are we below? Where did we say that x-intercept was again? Was that 15? Okay. Yeah.
Would be 1 from 1 to 15
Yes. Brackets, parentheses.
parentheses.
Parentheses for both. Alright, so the dotted graph is below the x-axis from 1 to 15. The question at hand is where are we below, but notice how at 1 and 15 you are on the x-axis. So we cannot include those, meaning we would have those brackets. Good. I think we're doing okay with all of those. What if we were to try something that we haven't really formally discussed together? Okay? I'm hoping that we're getting good with function notation and what it represents and how we can read it and understand it. What if I were to ask you something a little different? Okay, I want you to think about what this is asking us to find. So this time, what if we were to take the f graph times the g graph? We want to figure out where that would be less than 0. Can we think about what needs to happen or what we should be looking for to satisfy that question? What do you think?
Wait, so would we be multiplying the y values?
Because f of x is the same thing as y. So if you were to take the y value from the f graph and multiply it by the y value from the g graph, your answer would be less than 0, meaning something negative. So can we think about if we're going to multiply two things together and our answer is negative, yeah?
Would you be multiplying a positive and a negative?
That's your only option, right? If you're multiplying two things together and your answer is less than 0, meaning negative, one of those two things has to be negative, right? So what should we be looking for on the graph? We need one y value to be positive, another one to be negative. What's the relationship between the graphs? Can you describe where those might happen? Where one y value is positive and the other one's negative? What do you think, Mike?
Like between 1 and 9.
Between 1 and 9. You're close. I like between 1 and 6 a little bit better. You had part of that in there. Let's see, if we want, let's just say in general, okay, if we want the y value from f of x to be positive, where's the f graph located? If you have a positive y value. You are above the x-axis. What if the y value from f is positive, that means the y value from g graph is negative, where would the g graph have to be if it has a negative value? Below the x-axis, right? Okay, if one's positive, one's negative, one has to be above, the other one has to be below, or vice versa, because we could switch them. So we're trying to analyze on this graph where are f and g in opposite places, meaning where's one above the x-axis while the other one is below. That would give us a positive value and a negative value. So let's go ahead and write that down. F of x and g of x are on opposite sides of the x-axis. Meaning one graph is positive and the other one's negative. If we multiply those together, we'll get a negative answer, something less than 0. So think about it. As you drag your pencil across, where does one graph in the or start positive and the other one's negative? Can we find it? Do you see it, Sebastian? Okay, so from -9 to -4.5, notice how the solid graph is below, whereas the dotted one is above. I like that. So we'll do -9 to -4.5. Brackets or parentheses is the question. What do you think?
Parentheses.
Why?
Well, negative 9 is an open circle.
Mm-hmm.
And then for negative 4.5 is on the x-axis, so then it'd be 0.
Okay, so this is where we really have to pay attention. Open circle most likely means there's no point there for us to count, even though there is one here. So we cannot include at negative 9. If we look at negative 4.5, we need one function above and the other one below. Notice how this solid function is on the x-axis, not below it like we need it to be. So we cannot include that negative 4.5. All right, let's keep dragging our pencil and see what happens. Looks like the next one is from 1 to 6. Notice how one graph is above and the other one is below. After 6, they're both below, so we can't really count that. So we'll throw in a U, and we'll go from 1 to 6. Notice how at the value of 1, the dotted graph is on the x-axis, not below it like we needed it to be, so we cannot include that point. And at 6, the solid graph is on the x-axis, not above it like we need it to be, so we cannot include that point. Is there another interval? Can we keep going? You see it, Adam?
10.5 to 11.
Very small. Okay, so from 10.5 to 11, notice how the dot or the solid is above and the dotted is below. So we'll do another U, and we go from 10.5 to 11. All right, so we got to ask ourselves bracket parenthesis. What do you think, Alex?
For 10.5 parentheses and for 11 I have brackets.
Why can you include 11? That's good.
Because both of them are on closed circles and they both are, well, either above or below the line.
They're perfect. Okay, so at 10 or 10.5, notice how the solid is on the x-axis. We cannot include that because it has to be above. But at 11, we have closed circles on both graphs. And notice how one point is above and the other one is below. So closed circles answers the question. We can include that value. Okay, we're going to work our way all the way through. Let's try a similar one. Okay, the next one. What if we were to multiply the two graphs together, but this time we got a positive answer, something bigger than 0? What do you think we should be looking for on the two graphs? What do you think? Yeah.
Well, either they're both positive or they're both negative.
Okay, if you're going to multiply two things together and your answer is positive, those two things are either both positive or both negative. So if f of x, g of x, whatever you want to call it, those represent y values. We need the y values to both be positive, meaning above the x-axis, or both be negative, meaning below. So it looks like f of x and g of x are on the same side of the x-axis. Okay, they're either both above it or both below it. So we're going to see where that might happen. So looking at your graph, let's see. Looks like negative 4.5 is a good starting spot. And we'll have to end at 1. Let's see, at negative 4.5, the dotted graph is on the x-axis, so we cannot include that. And at 1, the dotted graph is on the x-axis, so we cannot include that one either. Okay, we're either both above or both below. Is there another one? Do you see it, Adam? Yeah.
From 6 to 10.5.
Let's see, 6 to 10.5, the solid is below, and the dotted is below. I like it. So we'll throw in a U. We go from 6 to 10.5. At 6, the solid graph is on the x-axis, so we cannot include that. And at 10.5, the solid graph is on the x-axis, so we cannot include that one either. Okay. Any other ones? I think we're good. We can't go past 11 because that's where the solid graph ends. So we don't have any more y values to actually use. Okay? Do those make sense? Even though we haven't really formally discussed them, okay, we can think about the function notation. Y values, what do they mean? Above, below, positive, negative, what's going on? All right, let's go ahead and try some more. We'll flip it. This one's going to be a little bit different. So they're giving us a graph of h of x, and I think they're just going to ask us a bunch of questions about it, whether they're function values or equations, whatever the case may be. So graph of h of x. First thing they want us to do is identify the equation. So if you really take a hard look at the graph, notice how it's most likely going to be piecewise because we have all these different shapes going on. So piecewise functions, if we start them out, we kind of have the big bracket. And it looks like we have three shapes. We have a line, a parabola, and what do you think this little middle section is? What shape of a graph does that look like? Yeah?
A square root.
That's a square root. Okay, so we're going to have three equations. It looks like we need a linear, a line, and then what type of equation makes a parabola? Do we know the name? Yeah. Quadratic. Okay, so let's go ahead and try the line first, just because as we read left to right, that's the first one that shows up. So if we're going to write the equation of a line, we got to figure out slope, bless you, and y-intercept. Pick two good points. Rise over run looks like 2. So we can write 2x. If we were to continue that slope, where does it look like it would cross the y-axis? Yeah, I'd agree. Okay, so 7. So when you're writing a piecewise function, you have not only these different equations to figure out, but you also have that domain piece or the constraint part that's telling you where the equation actually shows up. So if we look at this line, notice how it starts at -6 and it goes to -3. We can include -6, but we cannot include -3. So in terms of our I guess inequality here, we can go from -6 to -3, or sorry, -3, yeah. And our x's are trapped in between those values. Notice how the x variable is in the middle. We can include -6, so that would get a bar, but -3 would not. Okay, so we figured out the equation, but we also figured out where it shows up on the graph. Let's go ahead and try the square root one next. Okay, this is where it gets a little tricky. So this open circle is like the beginning point on the square root graph that typically starts at the origin. Can we use some transformations to our advantage to help us write the equation? What do you think, Sebastian? Okay, it was an x-axis flip, because normally the square root looks something like that. Notice how it's flipped upside down, because now it's going that way. So we definitely have an x-axis flip. What does that look like in the equation? What's in the equation that signifies x-axis flip? Yeah?
Well, the x is in the square root, and then you put the negative in the square root too.
That would be a y-axis flip.
So you put on the outside.
It's on the outside. Okay, so we need a negative sign on the outside of the square root. That's going to cause it to flip upside down. Are there any other transformations? You see more, Sebastian? Left 3, up 1. So how would those show up in the equation? Yeah?
Well, the up one would be +1 on the outside,
Okay.
and then the left 3 would be +3.
+3 on the inside. Yep. That's the tricky part. The left and the right do the opposite of what you would think in the equation. So if it moves left, it's actually adding. Okay, I like that. So we flipped it upside down and we use the transformations to figure out the rest of the equation. Now we'll go ahead and write the interval, like where it shows up. So this one goes from -3 to 1. X's are trapped in between. We cannot include -3, but we can include 1. So that'll get a bar. All right, one more. We have the parabola, which is quadratic. So we're going to need something being squared. Can we use some transformations to figure out the rest of the equation? Up, down, left, right, flip, stretch. Anything going on? You see something, Jordan? Yeah. Yep, it's flipped upside down, so we got another negative on the outside. Can we figure out if it moved left, right, up, down? Go ahead, Sebastian. Alright, so the vertex normally starts at the origin. Looks like it moved up 5 and right 3. So how would that show up in our equation? Up 5, right 3. You want to keep going? Yeah. Plus 5 on the outside. Good. Alright, so let's go ahead and write the constraints. We go from 1 to 5. X is in the middle. We cannot include 1, but we can include 5. So we'll get that bar. Alright, so transformations, kind of always coming back to that in terms of these equations. We can use those to our advantage, looking for up, down, left, right flips. It makes equation writing very quick. Okay, looking for those shortcuts. Alright, so let's go ahead and try to find the domain for f of x. We'll go ahead and drag our pencil left to right, ask ourselves, where does it start, where does it end, do we have to skip over any points? Looks like we start at -6, and it has a closed circle so we can count it. As we drag our pencil across, do we ever come to an x value that does not have a graph, that does not have a point? Yeah.
-3.
-3. So we got to skip over that. We do have more graph to trace, so we'll throw in the u. And our pencil previously stopped tracing at -3, so that's where we will pick up with the next one. So as we continue to trace from -3, we got to ask ourselves, when do we come to an x value that does not have a point? Or maybe we just keep going towards the end. What do you think? Something's going on at 1. Okay, do we have a point at 1? There is a closed circle. Okay, so we will keep dragging. Open circles are good things to be aware of, but as long as you have a point there, we can still count it. Looks like we'll just keep going till 5, right? And we can include 5, so we'll have that bracket. Okay, open circles, be aware of them, but as long as there's a closed circle, we can keep going, meaning that point is there at some place. Let's do the range. So low to high, we start at -5. Closed circle, so we got that bracket. As we continue to trace up, do we come to a y value that does not have a point at all? Maybe that's a better phrase, at all. If you get to 1, that might be a little tricky, because notice how we have open circle, but we do have a closed circle. That means the 1 value can be counted. So if we continue to trace, looks like we'll end at +5, and we had that vertex there, so it can be counted. We'll have a bracket. We doing okay? Good. We're going to skip this one. We'll probably save that one for tomorrow, but we might be able to tackle some of these ones. Identify the values for x so that h of x equals 0. Remember, this was the graph of h. So what should we be looking for on the graph if we want the graph to equal 0? What are we looking for? Yeah? The zeros. X-intercepts, or roots, yeah. So if we take a look, looks like we only have 2. So we'll say perhaps -3.5 and -2. What about the next one? H of x is greater than 0. What should we be analyzing on the graph? Yeah.
Just looking for where it's above the x-axis.
Okay, so above x-axis. Maybe you want to trace in those spots. Okay. All right, so it looks like we start at -3.5, but we are on the x-axis there, so we cannot count it. Notice how at -3 we have an open circle, so there's no graph there to physically count at all. So we're going to have to skip over -3. We do have more sections. If we skip over -3, that's where we'll pick up the next interval, and it looks like we'll end at -2, but we're on the x-axis, not above it, so we cannot include that one either. So even though this looks like to be one interval, you have to break it up into 2 because of that open circle. There's no point there to actually count. We do have the parabola though to do next. So that one goes from 1 to 5. We cannot count 1 because of the open circle, but we can count 5 because it is closed and above the x-axis. So that one would get a bracket. We doing okay? Can you guys try the next one? H of x is less than 0. Where is it below the x-axis? Right, so the first one's -6 to -3.5. Question is, can we include them, can we not? Brackets, parentheses, what'd you choose? What do you think, Cole?
You can include the -6,
But not the -3, right? So closed circle below the x-axis satisfies everything. We can include that point, but this one is on the x-axis, not below, so we cannot include it. Next one is from -2 to +1, bracket, parenthesis, what'd you choose? Good, Alex, yeah.
Parentheses for the first one and brackets for the second one.
I like it. We are on the x-axis at -2, not below, so we cannot count that. At 1, we have a closed circle and it's below, so satisfies both questions, both parts. We can use a bracket. How'd you do? Good? All right. We'll stop there for today. We'll finish up the next few tomorrow.